going to discuss about the IUPAC nomenclature of compounds containing more than one functional group. Before moving on to the steps of nomenclature, we will know about the class names and substituent names of some functional groups in their priority order, right? So here we have functional groups and their substituent names. These are arranged from the highest priority to the lowest priority. That means if two substituent groups are there in a hydrocarbon, we have to give the priority to the upper classes first, right? So in nomenclature, we have to consider about this priority. So remember them in order. So if a hydrocarbon contains COOH, that is a carboxylic acid, and to show that it is a carboxylic acid, after the name we add the suffix oic acid. So we know that it is a kind of carboxylic acid. For the esters, we use OAT. COCl, that means acidic chloride. We use oil chloride. CONH2, amides. We use amide itself. And CN means a nitrile. The substituent name is cyano and class name is nitrile. CHO is there in aldehyde. Formal is a substituent name. And AL is used as a suffix. CO is for ketone. Oxo is used as a substituent name, and on is the suffix. OH is in alcohol and substituent name is hydroxy. Class name or the suffix is OL, ol. NH2 amine, substituent name is amino and class name is amine. Here for the functional groups fluorine, chlorine, bromine, iodine and NO2, there is no homologous series, just two atoms, O1 atom is there, no homologous series, right? So there is no name. Substituent name is fluoro, chloro, bromo, iodo, nitro. So they have least priority. In IUPAC nomenclature, functional groups are arranged in their priority order. The functional group with the highest priority is called the principal functional group. Other than the principal functional group, remaining functional groups are called substituent group. Now we will discuss about the steps of nomenclature one by one. First of all, we have to identify the longest hydrocarbon chain which consists the principal functional group and any double or triple bond. So here you have a hydrocarbon given. We have to identify the longest carbon chain which consists of the principal functional group or double or triple bond. So here double bond or triple bond is here. So we can consider this as the longest hydrocarbon chain. And you can see here COOH. COOH is there as a principal functional group. And here this is the double bond. Second step is number the hydrogen chain. We have to consider three things in numbering the hydrogen chain. They are, first of all, we have to consider principal functional group gets the lowest possible number. Or else, if the principal functional group get the same number when numbering from both sides, we have to get the lowest possible number for the multiple bond. And if the principal functional group get the same number from all the directions, and if there is no any multiple bond, in such situations the lowest possible number is given to the substituent group, right? So here, if we think about this, here you can see a functional group. If I named it, number it from this direction, 1, 2, 3, 4, 5. For this direction, 1, 2, 3, 4, 5. So here we have there is a functional group. Functional group gets two different numbers, 1 and 5. So I have to consider the numbering from this direction to this direction. So the functional group gets the first number. So I'm going to select the numbering as 1, 2, 3, 4, 5. Right? Then the next step is derive the hydrocarbon name using the name designed for the number of carbon atoms and suffix of the saturation or unsaturation with its position number. So here 5 carbon are there in the longest hydrocarbon chain. So it is a pent. And there is a double bond in which carbon? Third carbon. So that is ene, a pentene, right? The next step is we have to add the suffix designing the principal functional group. What is the suffix for the principal functional group? For COOH, here you have carboxylic acid. It is a type of carboxylic acid. The suffix is oic acid. So we have to select the suffix as oic acid. Oic acid is the suffix here. And the next step, add prefixes designing the substituent groups along with their position number. So now we have to consider about the suffix here. Now we will consider about the suffix here. Here, for the second carbon, a methyl group and OH group are attached. And for the fourth carbon, another methyl group is attached. So here, for 2 and 4, methyl are attached. And for the second one, OH group is attached. For OH group, what is the suffix we are using? What is the prefix we are using? Hydroxy. Hydroxy. So we can compose the name after knowing these things. So then build the IUPAC name as follows. Substituent groups with position numbers are placed first. So here 2-hydroxy, 2,4 dimethyl 3 pentanoic acid. So this is the name, IUPAC name, according to the steps discussed. After doing that nomenclature, did you understand something here? If this, if the if these compounds are taken as substituents, we have to use the substituent name. If these are used as the principal functional group, we have to use these names, right? So that is the difference. So here, these do not have a substituent name, no? That symbolizes that these do not be the substituents. These always be the principal functional group. These can have the both. It can be both a substituent or principal functional group. So that is the end of the lesson today. Thank you for being with me till the end.